Hey math kids, today we're going to talk about Euler's form of complex numbers. And so for any theta contained on the set of all real numbers, e to the I theta equals cosine theta plus I sine theta. So we're going to use this relationship today. And then it says evaluate e to the negative I of pi fourths. And then also I to the negative I. Okay, so we'll start with this one, and we're just going to use this relationship. So we're going to say cosine of negative pi fourths, because to write it like this, we could rewrite it as I times negative pi fourths. That's where that's coming from. Plus I sine negative pi fourths. Okay, and then if we look at a unit circle, negative pi fourths is going to line up with pi fourths, which is square root of 2 over 2, square root of 2 over 2. So down here, the x's are positive, but the y's are negative. Okay, cosine is an x value, so that's square root of 2 over 2, plus I square root of 2 over 2, minus, because it's negative. And that's it for that one. Okay, and then when we're doing I to the negative I, we're going to think of I being equal to 0 plus 1I. And when we do that, we have cosine. Let's draw it out. So we're right here, and that's pi halves when we go there. And so we're going to get cosine of pi halves plus I sine of pi halves. And when we do that, we're going to end up with e to the I pi halves. So we're just using this in reverse. And so if we take that, then we can take that and raise that to the negative I. So this is equivalent to I, and then we're raising it to the negative I. So when we do that, we just use our multiplication rules, or our exponent rules, which in this case is multiplying the exponents. So we get e to the negative I squared times pi halves, and I squared is negative 1. Negative 1 times negative is going to be a positive 1, so that's e to the pi halves, and then we're done. If you need additional help, please come to Math Lab. Till then, calculator.